All right, good morning, seventh graders. We are going to work on lesson 5. For this lesson, I want you to remember the equation D equals rate times time. That is distance equals rate times time. We did this in a few units back. So an airplane moves at a constant speed of 120 miles per hour for 3 hours. How far does it go? So remember, D is equal. So the rate they're going is 120 times 3. Okay, which is going to give you 360. All right, you're going to do that for the next 2 warm-up problems. A train moves at a constant speed and travels 6 miles in 4 minutes. What is the speed in miles per minute? The distance would be the 6 miles, and the 4 minutes would be time. So you are solving for the rate. A car moves at a constant speed of 50 miles per hour. How long does it take the car to go 200 miles? Complete this problem as well. Hit pause, and when you're ready, we'll move on to our next one. Okay. 4, going left, going right. Very exciting. After each move, record your location in the table. Then write an expression to represent the ending position that uses the starting position, the speed, and the time. The first row is done for you. So, starting position is 0. Look at the 0. And the direction is right. Going this way. Positive. Yay. The speed is units per second, 5. Time per second is 3. Ending position is plus 15. So see 5 times 3 plus 0, you get 15. Now, if we move on to the next one, you have start at 0, but we're moving left. We start at 4, or our speed is 4, and our time is 6. So we got to remember it's going left, so it's a negative 4 times 6. 4 times 6 is something, 24, but it would be negative 24 because it is negative 4 times 6, so it'd be 0 minus 4 times 6. Now complete it for the next, or for the rest of the table, I should say, not next. All right. How can you use the direction of movement in this expression? So the direction of the movement, meaning you're going left or right, is based on whether it is add or subtracted, right? So going to the right is a positive 5. Going to the left is a negative 4. So the direction is based on whether you're adding or subtracting from 0. Using a start position of P, a speed S, and time S, write 2 expressions for an ending position. One expression should show the result of moving right, and one expression should show the result of moving left. So just like we did up here, 0 plus 5 times 3, 0 minus 4 times 6, which the position is 0. The speed would be 4, and the time is 6. So in other words, if we wrote it without numbers, P plus S times T. Or if we went into a left direction or a negative direction, it's P minus S. Ooh, S. That's 5 now. Times. Cancel. Times. Stop. What is going on? technical difficulties, times t. There we go. Sorry guys, that was some technical. Alright, now velocity. This is essentially the same thing we have just done. But remember, we're multiplying negative and positive numbers. So pay attention to those negative, okay, no, it's not working, and positive numbers, okay? So a traffic safety engineer was studying travel patterns along a highway. She set up a camera and recorded the speed and direction of cars and trucks that passed by the camera. Positions to the east of the camera are positive, and to the west are negative. Vehicles that are traveling towards the east have a positive velocity, and vehicles that are traveling towards the west have a negative velocity. Okay, I think that's important. That's like the second time they've told us that. Complete the table with the position of each vehicle if the vehicle is traveling at a constant speed for the indicated time period. Then write an equation. So if we look at this first one, they are going obviously to the east because it's positive. Time after passing the camera, 10 seconds. They are multiplying 25 by 10 to get 250. See the equation right here, over here? So if we did negative 20 times 30, it would be 600. Or our equation is negative 20, if my pen will write, times 30. Okay, my pen's not writing today, guys. I apologize. You're going to do that for each of the remaining table boxes things. If a car traveling east when it passes the camera, will its position be positive or negative 60 seconds after it passes the camera? If we multiply two positive numbers, is the result positive or negative? Think about that. So for number 2, if it is traveling east, meaning it's positive, will the position be positive or negative 60 seconds after it passes the camera? If we're multiplying two positives, we always get a positive. Okay? A car is traveling west when it passes the camera. Will its position be positive or negative 60 seconds after it passes the camera? If we multiply a positive and negative, is the result positive or negative? So it would be a negative time. Ooh, stop it today. Positive is always going to equal a negative. All right. Please do not forget to read the summary and move on to your practice problems. You guys have a great day.